Good morning and hello everyone, and welcome to today's webinar in which we are diving into the topic of antenna development and the key considerations for market approval. My name is Marius Winsler, responsible for marketing here at CETECOM, and I'm more than happy to host this event today. It is a special occasion because I'm joined by Jukas Jöstedt, CEO of Radientum, and Markus Ritter, CEO of CETECOM. As this webinar we are doing the first joint webinar today with Radientum and CETECOM. So welcome Juka and welcome Markus. We are going to explain the topic of antenna development, which will be covered by Juka, and then switch to the key considerations for market approval, which then will be presented by Markus and myself. Before we actually start with the content slide, I would like to give you some brief administrative information. As always, you will receive the presentation slides following this webinar, so there's no need to take any screenshots, etc. In addition, we will also provide you with the link to the recorded version. You will, of course, also have the opportunity to ask questions about today's content. So if any questions come up during the webinar, please do not hesitate to raise them via the webinar software, and we will answer them at the end of today's event. As the content is pretty packed today, there won't be like 20 minutes of Q&A, but we're trying to focus on 10 minutes Q&A. If there are so many questions coming up that we are not able to answer them during the webinar, we are going to create a Q&A document and we'll send this to all participants afterwards as well. We just want to make sure that each and every question will be answered, even if there is not much time left during this webinar. But now we want to start with our presentation, and therefore I would like to hand over to Juka.
Okay, thank you, Marius, and good morning, good evening, and whatever time you have there when you are listening to us. So, like I said, my name is Jukas Jöstedt. I'm the CEO of the Radientum, and I'm here to tell you about the antenna design. Radientum is an antenna and RF engineering company, so we have quite a lot of background from this topic, and that's why I'm telling this for you now. On the agenda, I will first give the motivation why does the antenna performance matters. So that what is the things where the antenna performance is actually affecting on your device, and how your antenna is doing. Why should you care about that? So I will talk a bit about that. Secondly, there is this main parameters for antenna performance, how those are measured, and what are used for that, and what you should know about that. Thirdly, there are practical experience-based pitfalls, what we have seen in the antenna integration, so during R&D. I will share some details on that, and then talk about the need of pretesting during the R&D at the last part. So altogether, this is aiming to really, sorry, I have to get that one. Aiming for that, how to ensure success in certification already during the R&D. So that's the thing what I'm focusing here now. All right, then why does the antenna performance matters? So your device need to comply with the regulatory requirements. So it can be the CE mark, FCC, or UKCA, depending where you are aiming for your product to be launched. And there are different kind of terms or things to measure. So effective isotopic radiative power is one of them, or specific observation rate. So the first one is basically the maximum energy what is radiated in one direction. So the absolute max on 3D around your device. SAR is then the energy what is absorbed to your body. And these are that kind of parameters that you can't fail and if you fail, you don't pass the certification. So you should really take care of these already in the during the R&D. Second one is network operators. They have their own requirements also. So here are examples about the cellular, which is the AT&T, and then this non-cellular, which is LoRa or Sigfox, and then there can be numerous of other carriers also. Typically, these are looking the TRP or TIS. Total radiated power is the 3D energy what is radiated out from your device. So it's calculating all around your device. So 3D, and that's sum of everything. So there is this antenna, then there is this PCB or cable losses, and then you have the RF, what is like the transmit power. So this is like the combination of everything. Then you have the TIS, which is then on the sensitivity, so receiver side, it's basically the same thing, that it is the total 3D shape around your device, including everything, antenna losses, noises, and everything. I will talk a bit more about this AT&T on the cellular side, because they have a pretty good requirement on the network already. So there's a link for the IoT devices.att.com. So there is the specific requirements for a small form factor, large form factor, wearable device, and you have a different kind of requirements for each of those. But why you should care about these when you're starting your product development? It's a thing that AT&T is really good example. So for example, if you are planning to build an asset tracker for Cat M1, and your plan is showing that, okay, my device is 110 millimeter of length. And then you go to the certification. So AT&T is defined that that kind of device, the requirement for the TRP is 18 dBm. But there is a catch. If you optimize your device to be 107 millimeter or shorter, so 106 millimeter, your TRP requirements is 10 dBm. So there's an 8 dBm difference. And how does that affect on your product development? It's much more easier from the RF and antenna point of view. It's cheaper. So in a way, the 1 millimeter change can have a significant change to the effort what you need to do in the R&D. So that's a really important thing to notice. Then there's a third group, which is basically the end user of your device who is caring about the antenna performance. So how the device is performing on the field. So antenna has effect on the battery life, range, data rate, and also much more other topics. But for example, if we take this sub 1 gigahertz LoRa or Sigfox device, for example, gas or water meter, those are installed typically in a difficult environment to the RF, meaning that it can be underground in the basement. So in this kind of cases, your antenna performance is really defining how well your device is performing on the field. And then it comes for the customer satisfaction when you do that. The requirements are different for each technology. For Sigfox, for example, there is this best class 0. It's 14 dBm EIRP, so it's 14, but they do have also recommended maximum. So in the Sigfox, actually, they have a window where AT&T, they have just a minimum. So it depends by the technology what you are using, what is the requirement for that. But then what is actually important when you are selecting the antenna solution for your device? So, so what is important? Simple, you only have to understand the simple Maxwell equation, how the electromagnetic waves are working. Well, actually not true. Our job is to understand this one. Your job as a device owner is to make a compromise between basically performance and the size available for the antenna. So these are in a way based on the physics that when you go in the smaller size, you will get less performance. It's a rule of thumb. of course, there are tricks what can be done, and one of them is for example, if you have a budget for a, let's say, wearable device, and you have a budget to invest on the antenna performance, you could use, for example, LDS technology for the antenna, so meaning laser direct structure. So basically there you are printing your antenna inside the mechanics enclosure. So you are using space what is not used for anything else for the antenna radiator, and then by doing that you can like increase the ground plane size virtually, or this is kind of like cheating in the rules that the length is something, but when you're adding the antenna on top of or inside the mechanics, you can make the ground plane longer and you can get better performance. So it means better TRP, and it means easier acceptables on the market when you are meeting the criteria. So it's a compromise, and always everything what is said here, it's a compromise of the technology and your device. So if you have a GNSS, you should have the right hand circular polarization radiation, but you can do also the linear radiation pattern, use that one, but you lose the performance. So it's a compromise of many things. So price, size, performance, and acceptance on the market. But then how you then can compare your antenna solution if you are buying or selecting what kind of antenna component you are using from the market. So this is actually interesting topic, because how to compare this one. So there's 3 examples of antenna components freely available, and this data is also from the data sheets. So let's assume that once again I'm using or making an asset tracker with LTE, so Cat M1. So looking for the low band frequency range. So this is support the US band or Australian band 28. So the lowest frequency 698. It's exactly the same on all the models, so no difference there. High band support is also the same, going up to the 2.7 gigahertz. For the option 2, there is a GNSS supported also. So if you plan to use that, it's in a way 1 point for the option 2. If you look the size of the antenna, then you can see directly from the numbers that actually the smallest one is now the option 1. So it's the smallest component and smallest clearance around the antenna. Antenna always needs clearance around it, because it need to breathe there. It cannot be any metallic around there. So the clearance is defined there. So 1 point for option 1 from that point of view. Then looking from the low band specifically, the efficiency number, which means that how much power you're actually losing in the antenna. First one is saying total, second one is saying average, and third one is giving 3 different figures. For this, it's a bit difficult to compare, because we don't know without looking at the graph that how the total is defined. Average, in a way, it's clearly understood what is the average, but then it can be really good or really bad, because we don't know unless we'll check the actual chart from the performance. This is in a way clear, but then we see that there's a quite big difference between the lowest channel and the highest channel on the GSM. But my point here is that you actually can't compare these numbers against each others. And the reason is that the reference port size is 142 millimeter in option 1, 120 and 110 on this one. So this is directly affecting on the antenna performance. So the longest one, basically, it's a rule of thumb once again, longer PCB ground plane will give better performance. So to be able to compare these 3 together, you should have an environment what you are using in your product, and then seeing which one is best for you. Okay, then moving on to the actual this one. So I was talking about the PCB length versus performance. So this is made a custom antenna on the PCB, same way as a component specification are set. So the high band performance, typically, it's not a problem in any of the product. It's the low band. That's always, if you can do the low band, you can always do the high band, I would say. And this is optimized for the every use case, so every length of the PCB. And there was 140 in the previous slide, and that's really quite perfect antenna there. But if your device is actually then 50 millimeter length, you will drop really a lot. So basically you are dropping about 6 dB, which basically means that you have a half of the range anymore available. So this is just to highlight that the numbers, what you are seeing from the specification, you really have to understand what you are reading and how to compare those. Then there's another one is this, what is good enough for your. So this is one component specification. This is the high band performance. Now it's in the percentage, which is there set, and this is the low band. So the specification for this device says that it's 40% on the low band. Well, you can see that it has a bandwidth which is, like I would say, reasonable to use only for this high part of the low band. And after that, its performance is collapsing. And when you are integrating this kind of component in your product, you don't know how much the frequency is shifting. Can you optimize it still back to the original operating frequency where it should work? So you can lose a lot of performance with your integration. And then everything this comes back that you have the operator requirements and you need the performance on the low band. So your bandwidth for the antenna component or custom antenna should be enough to cover and take care of the integration effect, what is happening in every device. So it's always there. So I will jump now for the actual pitfalls in the integration. So it's a bit slow. All right, now let's try now carefully. So most typical, I would say, is the late RF design start. So it is true that 80 to 90% of the antenna performance is defined by the antenna location. So this is really important. So when you are planning your device concept, you should take this into account, that it's the location that's most important one for the performance. Then I already talked about that, in a way, wrong specification. And for this, I'm meaning that the off-the-shelf component specification is always for free space, meaning that there's only PCB. You don't have the battery, you don't have any flex on the design, you don't have any environment included there. And typically you don't have that big device nowadays, so it's much more smaller. So you don't get the performance what you expect to get from the datasheet, because it's individual for each of the device. And that comes to that antenna is not the component only. And by this, I'm meaning that the battery wires, flexible PCB, everything is part of the antenna performance. These can generate that called parasitic resonances, so that actually the energy resonates inside the device and it will not radiate outside at all, what is the thing what we want. And then on the industrial application, we are seeing quite a lot of these potting materials. So if you need to fulfill the device with or fill the device with epox or silicone or something else to guarantee the functionality in the industrial environment, that will retune the RF on the PCB trays, passive components, and antenna. So everything is effective if you put that one. It can be compensated, but you really have to take care of that. You will do it. And here's an example of the simple asset tracker device where the concept level things are decided. So it's looked at, okay, the GNSS antenna is there because that's critical for the performance. Battery is located in the middle, and you have Bluetooth and Wi-Fi antenna on the other corners, and then the NFC course, because these everything is seeing each other's. So this is what need to be done on the concept level, and this device has a dual band GNSS support for L1, L2, so quite critical for the antenna performance point of view, the location of that one. Then continuing on the second slide of the pitfalls is that the RF design of the PCB has effect on the antenna. So typically there are grounding issues, that your ground is not good enough. So basically mean that there are different islands on the grounding level. You have wrong components. Though this is quite commonly seen that 10 nanohenry wire wound inductor does not mean anything else than wire wound inductor. So the value is not enough on the RF. So you need to know the component type really. So that's a quite common also. And the PCB RF layout can cause extra attenuation in many kind of forms. EMC issue is also what we are seeing a lot, and it's put that it's antenna's fault that GNSS does not work. But actually, it's typically what we are seeing, that uncontrolled changes to reference design cause EMC issues, and these are really slow and expensive to fix because you have to redo your hardware. There's no this kind of magic trick that you can fix it. And then one benefit, actually, it's not a pitfall, but what we are seeing, and I want to highlight, is that with early RF design, you can really reduce the variance on the field. And with that, you can reduce the certification test. Because antenna is a dummy component which doesn't know, or does it receive or send. And then antenna doesn't know that am I located in the US or Australia. So basically band 12 in North America is from the frequency point of view same as band 28 in Australia. So we can combine these smartly when we know what are the target markets. And you can also combine LTE with GNSS and Bluetooth in one antenna element if that's really needed for your application. So then how to succeed on this certification is that you really need to know your performance targets. So where you are aiming for, what's the user environment, and target for that. Do the RF concept simulation early enough, and do the RF testing, R&D testing, to know that you will fulfill. So this definition phase, this is typical product development cycle, what I'm going to show. So there you need to correct the requirements where you are entering. On the second phase, oops, there's a text a bit wrong now. You will select on the concept that is it a custom antenna, is it a standard antenna, where you place the antenna, what kind of topology, what kind of mechanical requirements there is, and then you actually do the design in the third phase. And there you can see the actual by the simulation. You can see the simulation results already in the concept, but then on the product design phase, you will also see the performance, what you will accept on the verification. And then you will have, it can be, by the way, it can be custom antenna or can be standard antenna. There's no difference on the workflow there and testing. It's exactly the same. So this testing phase in the R&D, you will do passive measurements for the antenna, active also to get the TRP and TIS, and you tune the antenna to match the requirements, because there's always a bit what you can optimize, but you should be ready after this one for the certification. So the key takeaways from my presentation is that start early with RF and antenna design. It doesn't need to be like much, but like one day with the RF expert, you will save lots of money in the certification and R&D. Antenna performance is really affecting every part of your device. So be like aware that it's really critical. An integrated antenna, it's not only a component. Actually, when you're placing an antenna in your device, the antenna does not radiate. It's the device body what radiates, and that's why the whole device is part of the antenna. You cannot fix the issues with the antenna by software. You can reduce the power consumption with power saving modes, but it doesn't improve the antenna performance. And always, when you do the integration compared to the datasheet, it changes the component behavior and you need to optimize it. And with the RF simulation, you know your performance beforehand, and you will save definitely time and money that you find the problems early enough and you will pass the certification. So I think that was my last slide. Sorry, this is jumping a lot. So thank you from my side. Actually, I can't get it back now.
All right, thank you very much, Jukka. So, and I think we are directly heading over to the second main topic, so the key consideration for market approval. So before handing over to Markus, I will provide a short introduction to that topic. So what are we going to deal with? So we are looking at the integration of radio technology and then the consequences for certification. We are covering the most important certification schemes and then the challenges for a global certification. First of all, I would like to raise the obvious fundamental questions before you actually really think about the certification process. So which radio technologies do you want to use in your product? What exactly does the integration into your end device really look like? And this is the important part as well, for which target markets should the product be certified? So this is the huge bridge between the content Jukka just presented and what we are dealing with. So there are a lot of examples of radio technologies that can be used individually or in combination. So obviously Bluetooth, Wi-Fi, cellular, radar, or even short-range devices. When we're looking into the integration, as a manufacturer, there are basically three main options to integrate wireless technologies into your product. So the first option is a device with an external radio dongle, so typical for Bluetooth, Wi-Fi, or cellular technology. And then the second one is also the most common one, so a device with a certified integrated radio module. And the third option, so a device with a not yet certified radio chip, but which is right now most common for mobile phone manufacturer using their chipsets. The consequences for the choice of integration. In option one with the external radio dongle, it is important to understand that only the dongle must be certified on the basis of the technologies used. The certification process for the other two options is a little bit more complex. Here it is important to understand that in the case of a permanent installed radio chip, so which was option 2 and 3, with the associated antenna configuration, predefined test scenarios or even the final product certification must be performed. This is also the case if the installed radio module or the antenna configuration is already certified. Although a successfully pre-certified radio module reduces the overall test effort, only the certification of the entire product is relevant for the market launch, for example, EMC testing, safety testing, as well as radio ERP is necessary. When we're then looking at the target markets, companies that want to market their products internationally face a really great challenge because the regulatory requirements are really diversified and there's no such thing as a unique worldwide approval. When we look at our certification map, you can see there that you have more or less dominant certification regimes, so the CE marking or the requirements for the Radio Equipment Directive and the FCC certification, but you also have like plenty national certification regimes with national requirements, and you have a lot of mixtures of requirements where the bases are on the RED or the FCC, but there are also national requirements mixed in there. So that brings me to the most important certification schemes, and quite obviously you have two really important ones plus another one in the context of the time frame. So the first really important one is the CE marking. As I just mentioned, the CE marking is mandatory to bring a product to the EU market, and by affixing the CE marking, it is really asserted that the product complies with the relevant European product compliance rules, especially with the Radio Equipment Directive. Looking to the US market, the FCC certification. So an FCC approval is really required for manufacturers to market their devices in the US. Without an FCC certification, the launch of devices in the US is not possible. Usually, these two have been our most important certification schemes, but looking at the change of scenery in the UK and the Brexit, we also highlighted the UKCA certification over here. The UKCA marking is a prerequisite for the approval of products within Great Britain. In the context of the Brexit, it really replaces the CE marking previously used. But we will go into a little bit more detail into that on later slides. And that's the point where we are going to show more details about the most important certification schemes, and I would like to hand over to Markus for that one.
Thanks for the good introduction, Marius. Also, very many thanks to Jukka for the great presentation of the antenna integration topics. It's now my time to also say hello to all of you, wherever you are. Hopefully it's not as hot as we currently have it here in Essen, Germany, with already 29 degrees by 10:30 in the morning. Let's go to the CE marking first. And CE marking in that case, talking about products coming with a radio interface that have to be, let's say, compliant according to Radio Equipment Directive, which is 2014/53 EU. Yeah, I think well known by all of you that the former RNTTE directive has been neglected, and since June 13th, 2017, all products coming with a radio interface have to be compliant according to Radio Equipment Directive, and this means devices coming with a radio transmitter, meaning transmit or receive, and also including receivers. And this was new with the Radio Equipment Directive. Until then, receivers have been taken off responsibility of RNTTE. So there are mainly two ways to gain, let's say, market access in the EU. The one is self-declaration of a customer. This is possible as long as you're using harmonized standards according to Radio Equipment Directive. The ADSI provides a list of those. We put in the link in this presentation. You can have it afterwards. Second is you're using non-harmonized standards. Non-harmonized standards do not have the hook for being compliant to all requirements coming from RAD. And this includes the usage of a notified body. The notified body itself will issue a type examination certificate, a TEC, a tag, naming your device was tested according to all requirements coming from Radio Equipment Directive, but possibly not using harmonized standards. In general, if you're using harmonized standards and use a notified body on top, this is to be seen as an added value. This is kind of a quality feature. This is an additional certificate of quality for your device. Let's go through regulatory testing in a very short view. Sometimes we get to know the distributors, and mainly distributors, tell customers as long as they're using a pre-certified module, they do not have to do any testing afterwards. So this is rumors we have seen many times, have heard many times, and they still continue in the market. A pre-certified module is always a good story, and it helps you shorten your development process, helps you shorten your regulatory approval process, but this does not mean we do not have to test anything afterwards. The requirements from Radio Equipment Directive also include EMC. They include radiated spurious emissions that come from the respective radio standards. So all this stuff has to be respected. Getting a regulatory approval, doing a self-declaration, or let's say integrating a notified body. Third is electrical safety. Electrical safety is also part of Radio Equipment Directive. In this case, we took as an example the 62368-1 electrical safety. This is a standard that superseded the 16950, which ran out end of last year. Next one would be health. Health is also a requirement. Yuka already told us about the SAR values. SAR values are more or less integrated in the EMF. EMF measurements can take place, MPE, maximum permissible exposure calculations can take place, or in case we have a body-worn device with an output power of more than 20 milliwatts, requires a SAR measurement. This is what most people know from mobile devices like handies, whatever. Notified body can be taken in if non-harmonized standards, and it also is possible to work according to the Blue Guide of the Red Car Association, and also according to combined equipment. So whatever you have been testing with your pre-certified module, pre-certified radio module in terms of conducted measurements, these can be reused for your regulatory approval as long as the latest standards are respected. So if the pre-certified module is more or less an older one, most probably it's not been tested according to latest standards. If standard changes according to European law, there is no grandfathering allowed. So you have always be compliant to latest standards with your device. And if you're using a radio module that is more or less old, it is very possible that your device does not cover latest standards. We need an accredited test report. It's not sufficient if someone does this in a in a cellar lab on his own. And we still need the hardware software version. This is also a requirement coming from Radio Equipment Directive. Hardware and software version is to be issued in the declaration of conformity of your device. If this differs, at least you have to do some risk assessment. So in more detail, 301.489-1 electromagnetic emission. We're not talking about electromagnetic interference, as interference does not provide a direction. We want to have emission. This is clearly stating everything that comes from the device in terms of electromagnetic fields. This has been tested in conducted and radiated way. Electromagnetic immunity is the device is being harmed by electromagnetic fields, and we see whether the device keeps on working. This has also been done conducted for power lines and for any interface coming with a line length of more than 3 meters. Whether it's USB, HDMI, Ethernet, it does not matter. Every conducted interface coming with a cable length of more than 3 meters is to be respected here. And this also applies to radio products. And this is where I like to confirm what Yuka said. It's not only the module itself, it's the whole device. And it could happen that, for example, the HDMI or Ethernet cable radiates, and this is definitely not intended. EMC testing should always consider complete device or system. Interconnection, this is what I just mentioned with the cable length. Software should be application software. So for EMC testing, we need the application, the end application software, and very important, even if your device, maybe it's a washing machine coming with the CE sign, and you're putting a radio module inside the washing machine that is also pre-certified, both come with a CE mark. The whole device at a one may not be compliant. CE plus CE is not necessarily CE. Shortly to the radio standards. Radio standards, especially in radiated spurious emissions. Radiated spurious emissions, these are, let's say, emissions that do not come from the intended band. So if we're talking about LTE 800 and you see an emission in, don't know, 1 to 2 gigahertz, this could come from the device, and depending on the regime you're testing for, we're testing up to the 5th harmonic to see whether the device only sends in the intended band, and this applies to all radio technologies, whether it's LTE, UMTS, GSM, it does not matter, even for Wi-Fi and Bluetooth, which is taken as an example here from the 300.328. Use the latest version of whatever standard you have. Health and safety, just short. 2 standards been given here. Or for health, it's only one. It's 62311, radiation exposure to human body, coming with an MPE calculation or with a measurement. And the electrical safety 62368-1. This is a hazard-based electrical safety standard. So the engineers taking your product into closer look will test for what are the sources of hazard for the operator: heat, sharp edges, device taking flame, whatever, electrical shock. All this has been respected. Regulatory tips, some insights. We also suggest to pretest your device. If you're unsure, and maybe it's the first time you're running through a regulatory approval, plan for pretesting. We've seen so many devices failing during the very first test in the final regulatory approval, and then you have really time pressure, time to market. Your boss tells you, okay, device being in the market next month, and you're coming to CETECOM for testing, and CETECOM says first time testing, please go back to your lab and check again. This could be prevented. Take into account doing testing. Some of those tests could also be done at Radientum, just to mention. Pretesting, very good idea if you ask me. Ensure that all instructions of the module manufacturer have been observed during integration. Honestly, whoever does a radio module and does a pre-certification, they use a very, 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 very optimized board for their radio model to go through regulatory approval and certification. If they come with the CE mark, that's great. But they have a very optimized board. If you have a very small radio module and you put it to a motherboard and have a very long power supply on that, believe in me, this looks different. Carefully select antennas, going to Yuka, and accessoires such as power supplies. Perform tests if necessary to select correct component. When selecting radio modules, certification level frequency spectrum has to match your requirements. So this means if you're going to approach the Asian market, make sure that the radio module was tested for the Asian market. We've seen people buying a module in the US, taking a module that works very fine with the US requirements, and then going into Asia and having to adopt this module more and more and more and more and more, and they have several rounds taken. See to a device that covers all your bands you're going to achieve. Make up your mind about regulatory approval as early as possible in the design process. The earlier, the cheaper. If you have market entrance tomorrow and you're sitting in our lab today, this will take very long. This will be very pressurous for all of us, and this will be very expensive. Worldwide regulatory approval can be quite expensive and very time consuming. People telling us they want to bring their device into the whole world can achieve pricing in terms of, I don't know, 1 million euros something, and can expect this to be, let's say, about 1 year if you cover each and every country. So we have about 270 recognized countries in the world. CETECOM can cover with 220 of them, but this will not be done in 1 week, never ever. We can help you, but please bear in mind the time schedule. So coming to one of the mentioned regimes that Marius indicated in the beginning, if you want to come to North America and you want to take into account that your device runs in the USA, Then you have to respect the big book of rules coming from the Federal Communications Commissions, the FCC. FCC is a state-run organization in the US taking care for electrical devices being run in the US. And in general, a market approval as required by the FCC primarily means an approval of wireless technology devices in the US. Going into a bit of more detail here. In general, one has two options to get into the US market. The first one is certification and taking a so-called TCB. The second one would be a self-declaration process using the logo and having a responsible party in the US. These two routes have been enabled from November 2018 onwards, and these are the basic two routes that can be taken. Before that, they have been free, if I'm informed correctly. In order to make the certification process more efficient for those manufacturers, the FCC has appointed telecommunication certification bodies, the TCBs I've just mentioned, and those have the authority to submit and issue an application for certification within the framework of the FCC approval. So you show that your device complies with the FCC book of rules. Sad as it is, it's quite a read. To the TCB, and the TCB decides whether your device complies. The FCC does not decide. The FCC just stores the data, and they rely on their telecommunication certification bodies. So once certification has been completed by the TCB and approved by the FCC, the manufacturer is entitled to label the product with an FCC label, including so-called ID identifier, the so-called FCC ID. Very important, once you have tested your device and rules change in the US, your device is still compliant. So grandfathering in the US is allowed. You do not have to stick to latest standards once your device is tested, it's been approved, certified, and you bring it into the market same way you did as during the test. Difference to you. The bigger challenges of global certification. So, as been talking about, there are several regimes worldwide one could cover. Usually, it's not a single device, it's not a single software that has to be taken. We're talking about variants. You have to take care about national requirements. So if you want to bring your device into China, you have to respect in-country testing. If you want to bring your device to Brazil, you have to respect that the Brazilian authorities take at least 3 devices of your devices and keep them. You have to respect label validities. They could change. Coming to this next. It is very much advisable to first obtain certification for Europe, North America. So this is where we usually start if someone wants to bring the product into the whole world. Sorry, I have to laugh about this. We heard this so many times. Yes, I want to bring my device into the whole world. And afterwards, seeing timing and seeing costs, this usually broke down into, okay, I take Europe and US. We help you with that. Start with Europe, then do US, then do ISET, and then do the rest. It helps you reducing your lead times for all the other regimes. The example of the UKCA certification. Marius mentioned this in the very beginning as one of the important schemes. We mention it here as the demand for UKCA testing rises very much in the last weeks, last month, as you all know that the United Kingdom left the EU, and since end of last year, first grace period ended. All devices that have been shipped into the UK until end of last year are still valid. The CE marking remains valid in a transitional phase until December 31st this year, or you can do a UKCA certification. From beginning of next year, 1st January 22, UK CA certification is necessary. As of today, we do not see many standards in the UK being harmonized, and the procedure itself is about the same as we have with the Radio Equipment Directive. They have their own directives now in the UK, and these directives need harmonized standards. As of today, they do not have them. So with that, one needs a UK MCAB. UK MCAB is a United Kingdom Market Conformance Assessment Body. Unfortunately, as the European Union doesn't have an MRA, Mutual Recognition Agreement, with the UK, these cannot be the notified bodies currently working for the CE mark. If you're already seeking UK CA certification now, today, despite the transition period, approval process for the UK changes. We pointed out the different regulations we see here. It's not directive, it's regulation. And for EMC, it's EMC regulation 2016. For safety, it's a safety regulation 2016, and radio equipment is according a radio equipment regulation, not directive. As of today, these are more or less comparable to the EU directives, but wording is different, and we do not have the standards UK MCAB necessary. I could also give an introduction to Canada. Canada is more to the European approach than to the US approach, but looking into the time, I would say we give our questions some space here and skip that. If that is fine for you, you will get that in the presentation afterwards, seen, reading through, and with that, I think I would like to give the word to Marius to moderate the questions.
All right, thank you very much. So we are looking into the questions right now, and we'll give it a couple more seconds that you raise the questions. And there's one question about or for UCA. Basically, you mentioned TRP specifications, difference for AT&T. Was it right that 107 millimeter component have a minimum TRP of 18 decibel, while 106 millimeter component would only require 10 decibel? Can you reply to that one?
Okay, yeah, so there is this small form factor device which AT&T has defined that it's 107 millimeter of length or smaller, and that category has a different requirement for the TRP, and that's 10 dBm. And if you're above this 107 millimeter of length of your device, so let's say that 1 millimeter longer, so 108, the requirement is tougher, and that's 18 dBm. And so there's 1 millimeter change has a really big effect on your certification and or actually passing the requirement from the operator. So yeah, that's the behind. And then there are different kind of things also, that if it's a wearable, there has been defined the test, how it should be tested. So this should you also take into account. So if your device is wearable, let's say wrist wear or ankle wear, you have to actually test it on the wrist. And when you test it on the wrist, you have to do the development on the wrist, not on the free space, because there's no point to optimize the free space performance if your device is always used in the wrist position. But hopefully this answered. So two categories, over and under 107 millimeter, and there's 8 dB difference. And this is the lowest band, band 12. Band 4 and 2, the same requirements are 12 for the small device, 12 dBm for the small device, and 20 dBm for the bigger device. So the multiple categories, not easy to answer.
Okay, perfect. Thank you very much. I think this one is a good example as a question that it might make sense to have a follow-up on that topic to elaborate a little bit further, because there are so many variables to consider. So then I have two questions for Markus. The first one is regarding the Radio Equipment Directive. So do you expect any changes in the future with regards to the standards for the RED or the harmonization of standards?
Yes, I do. There's Article 3.3 in the Radio Equipment Directive. And we heard that Article 3.3 is going to be live, effective, and required from, I don't know whether it was March or May next year. Article 3.3 covers points like emergency call, so emergency call with mobile devices, and second most important for us is cybersecurity. So manufacturers have to declare that their devices cannot be, for example, manipulated by firmware or the air updates, and all this is secured. So this is one change we're going to expect. Second, ETSI is going to enlarge the emission testing range, frequency range. Usually emission testing as of today has been done between 150 kilohertz up to 6 gigahertz mainly. This does not include radiated spurious emissions. As I said, this is fifth harmonic that has been taken into account. Standard EMC, electromagnetic emission, will be tested up to 40 gigahertz. And it's been a grace period that is going to come. And after this grace period, we expect it to be about 2 years. The devices have to cover 40 gigahertz emission. Why do I stress this? This takes a lot of time to test emission until 40 gigahertz. Time is money, even if this is a management speech. So usually emission testing has been done 6 gigahertz, don't know. Dual polarization of the antenna takes 4 to 10 hours, don't know. 40 gigahertz will be a different story. It will take days.
Okay, thank you very much. And then we have like 3 or 4 questions which I can basically summarize. It's regarding the UKCA one. So do products that are certified in 2021 regarding CE need additional UKCA certification in 2022, even if they are already distributed in the UK?
If you distribute them any longer, you will need to change to UKCA. If your export to UK ends 31st of December this year, you're fine with that. From 1st of January onwards next year, you have to cover UKCA regulations. And if you still bring your device into the market, there's also no grandfathering. You know, in German you would say Bestandsschutz. Kein Bestandsschutz für die Produkte ab dem nächsten Jahr.
Yeah. And I definitely recommend the webinar we have on our Knowledge Center on the website, where we discuss an hour long about the UKCA and the requirements which are coming with this change. In the follow-up email, we will also highlight this webinar, because this is something which is really interesting and changed, and we are going to have a white paper published by end of this month as well regarding the UKCA topic. And then I have one question for Yuka. So what are the accepted uncertainties of TRP and EIRP for base stations at millimeter waves?
That is something what I cannot directly answer. So on the millimeter wave area, so we are actually working, it's not so commercial yet available, but we have worked already now 3 years with the millimeter wave up to 40 gigahertz, and we do have internal capabilities to measure the antennas up to 40 gigahertz. But there's no commercial experience yet from the base station or the ERP. So my understanding is that at the moment, TRP is not even the right terminology. There's a different one. My technical team knows this, but there's a different terminology for the millimeter wave area, and that's basically replacing the TRP, because there's the beamforming, and it's in a way millimeter wave are changing the way how radio waves are measured and designed totally. So it's a totally new world, but I'm happy to elaborate that more after this webinar if there are further questions.
Okay, perfect. No, and then looking at the time, there are a couple of more questions coming in. So we are basically doing what we suggested in the beginning, that we are taking all the questions coming in and then basically do a QA version of the or do a QA document for that, and then send all the questions, because some of them are really detailed in terms of technologies or even certain certification regimes. So I think we do not run over and let you proceed with your working day. I think that's for it now for the Q&A. So thank you very much, Jukka and Markus, for answering the question. As said, if there is anything coming up afterwards, feel free to get in touch with us. As indicated earlier, you will receive the presentation and a link to the recorded version of the webinar later today via email. In this email, there will also be a link to a short evaluation survey. In order really to improve our webinars and to evaluate the content, your feedback is really much appreciated. And in the next couple of days, as said, we will provide the answers to your questions in the Q&A document. Right now, it's left to say thank you. Thank you for your attention. Thank you for your participation. We wish you all the best. Thank you, Jukka. Thank you, Markus, for your content. Stay healthy. And as said, this was our first joint webinar. There's certainly a lot to come in the future. So thank you very much and take care.